Hi everyone, we're going to do day 8 today. We're going to be in notebooks for most of the period, and we'll have one question where we'll do packets, so you can have both of those out. So as you saw in the video, we're starting to do antiderivatives now. So this is really the start of the second half of calculus. Antiderivatives begin that second half of calculus, where essentially we go the other direction from what we've been going the first half of calculus. Your homework tonight, you got video 7-8. This video that we're going to do during the class period probably won't take the whole period, so you'll probably have a little bit of time to get started with that video in class. Okay, so a couple things. First off, notations. Depending on what you're given, that will tell you what your notation is for the antiderivative. So if you are given an f prime, then the thing that came before that, because antiderivative is going backward, would just be a regular lowercase f of x. Say you had g prime of x, then lowercase g of x would be your antiderivative. Say you had y prime, then your antiderivative would just be y. Other ways we've seen derivatives, dy over dx. You see dy over dx, then your antiderivative is just y. Now, something that's a little bit new is what if they give you little f of x and say we want the antiderivative? Well, the notation we use if we're given a little f of x and are trying to take the antiderivative is a capital F of x. And that's true of any letter. If we have little g of x and they want us to do the antiderivative, then we would use capital G of x. So just one thing with notation. Now, as we're starting to do antiderivatives here, we have to do essentially what we did when we first did derivatives. We only have basic rules for antiderivatives right now, and we need to always get it in the form where we can do our antiderivative. So in this one, how it's given, 3x minus 1 all squared, can't work with that, so we needed to FOIL that out. So if you write that twice and FOIL it out, we would get the 9x squared minus 6x plus 1. So I'd like the sub to pause the video for 1 or 2 minutes and allow everyone to see if they can write what the antiderivative of this would be based on what you saw in the video. Okay, we should have had this. So I always like to think of it as new exponent first. So in our first term, the new exponent, the exponent's got to go up 1, so we have x cubed. And then you divide out front by that new exponent, so we get 3. In the second term, the new exponent goes up 1, so it's 2. You divide out front by the new exponent, negative 6 divided by 2 is 3. Now, the thing that came before it must have been something that's linear. Or you could think of this as, this is really like x to the 0 right now. So when it goes up 1, it's x to the first. So 1's antiderivative is 1x. And then we need a plus c. Because there could have been any variations of constants added on the end here. If you wanted to check it, you take the derivative. So derivative of 3x cubed would be 9x squared minus 6x plus 1, and then the constant's derivative would be 0. Here's our next one. You can write it down in your notebooks. Now, we need to rewrite this in a way where we can work with the derivative. So we're going to divide each of them by 2x squared. Now, in the beginning of the year when I gave you a problem like this and had you do derivatives, lots of people wanted to bring it up and write it as something raised to like a negative power. That makes it so much harder and people are more likely to make errors. Just divide them each by 2x squared. So 3 divided by 2 gives you 3 halves. X cubed divided by x squared gives you x. 5 divided by 2 gives you 5 halves, and x over x squared is x to the negative 1, or 1 over x, however you want to think of it. So we're going to have the sub pause the video for 1 or 2 minutes and see if you can write the antiderivative for this one. All right, so our notation, we have little f of x equals x's new exponent should be 2, divide by 2 out front. So something, we're going to see this a lot. We're going to have to divide fractions by stuff. So if you are dividing by 2 using keep, change, flip, that's the same as multiplying by its reciprocal, so 1/2. So really the 3/2 is getting multiplied by 1/2. Multiply the 3 by 1, the 2 by 2, and we get 3/4. We are going to see that so much that you're going to want to be comfortable that dividing by a number is the same as multiplying by its reciprocal. Now the next term is the challenging one. We're going to have a 5/2, and x to the negative 1 is the same as 1 over x. And this is a special case, because if you raise the exponent 1, you'd have x to the 0, and you'd have to divide by 0 out front. And you can't divide by 0. So you need to think about what thing's derivative was 1 over x. And the answer is it was natural log. But when we do an antiderivative, we've got to do natural log absolute value of x. And the reason we have to do that is we know inside our natural logs, we can only have positive numbers. But in the derivative, as a 1 over x, those x's could have been positive or negative. So we have to do the absolute value there to ensure that it's only positives on the inside of the natural log. And then we've got our plus c on the end. Remembering those absolute values is one of the common things missed in this unit. Okay, here's our next one. We'll give you a minute to write it down. The sub, you can go ahead and pause and give 1 or 2 minutes to see if they can do this antiderivative. All right, so our notation, we should have little f of x. If you have cos, the thing that came before cos was sine, keep the 2 out front, so we'll have 2 sine x plus c. Now, it gets to be really confusing when we've been doing derivatives of sines and coses, and now we've got to do antiderivatives. So here's what I always suggest. Write out your sequence of derivatives off to the side. So when we did derivatives, it was sine, cos, negative sine, negative cos. Now once you have this sequence of derivatives, instead of going down for the derivative, we'll just work our way up for the antiderivative. So we are at cos right here. We need to go antiderivative, so we go up 1, so we're at sine. Okay, I see lots of errors on the sine and cos ones because people just don't take the time to think it out. Write your sequence of derivatives that we've seen all year, sine, cos, negative sine, negative cos, and then once you see it visually, just find where you are and go back 1 to get the antiderivative. Okay, you can write this one down, and sub, you can pause the video for a minute or 2 to allow the students to try this antiderivative. So we want to think about what thing's derivative is secant squared, and hopefully we remember tangent. We had dy dx, so our notation would be y, so we had y equals 5 tan x, and don't forget your plus c. If you ever want to check, just take the derivative and see if it matches the original. All right, so let's everyone go to packet page 3. So in the beginning, first half of the year, we saw things where I gave you a graph, and I wanted you to sketch the derivative graph. And the phrase I always had you think was the slope in f is the y's in f prime. Or in other words, the slope in one function is the y's in its derivative. Well, the y's in some function could be the slopes in the antiderivative. We're going to try going the other way. Now notice they're giving us f of x for the original, so our antiderivative would be capital F of x. So we want to use our y values of the graph given to us, and that's going to tell us the slopes in the graph we want to draw. Now, because of the constant, the plus c, what that really creates is a bunch of answers that is a shift up and down. That's what adding or subtracting on the end of a function does. So they've given us here that the graph has to pass through 0, 2 to help guide us. So I put a point here to start at 0, 2. And then what you want to think about is, okay, what is a number, or what is a y value that this is showing right here? So I thought, okay, this looks like it's maybe around -3. So what I drew in was a little line segment that had a -3 for the slope. Now, only draw in what I'm talking through to you. So these are the completed notes from last year, because I don't have a smart board with me at home as I'm doing this, so I'm using the completed notes to talk you through it. So we'll get to all the parts, but only draw in what I'm talking through to you. So draw in this line segment with like a -3 slope. Well, then let's go to a next key spot. Here we have a y value of 0. So in the antiderivative, we should have a slope of 0. So we've just got to draw in some place that has a slope of 0. Well, because this was decreasing here, we just want to make sure that slope of 0 is somewhere below it. So I just randomly drew a horizontal line right here. So draw a little horizontal line for yourself. So then I went to this maximum. So this maximum looks like it has a y value of around 2. So I just drew in a little line segment with a slope roughly of 2. Okay, and again, you're only drawing in these line segments so far. Well, here's a y value of 0. So I drew in a slope of 0. It's got to be above that line segment because this was increasing, it was going upwards. Well, now I went to this minimum here. This has a y value of like -1 or -2. So drawing a little line segment with a slope of like -1, -2. And then here we've got y values of something smaller, maybe like -0.5. So then I drew in a line segment with slope of -0.5. So you should now have 6 line segments. And all you do is you now connect them in with a nice smooth curve. It should have given you enough to guide and show you your shape of the antiderivative. And to check, you can see, do your slopes in the one that you drew match the y values in the one that was given to you? So here we have negative slopes, negative y values. Positive slopes, positive y values. All the rest are negative slopes, all the rest are negative y values. Okay, so it is tricky, but just remember the slopes in any function are the y values in its derivative. So if you're going backwards, doing an antiderivative, the y's will then tell you what the slope should be. All right, we're going to go back to the packet for the rest of the period. So sub, you can pause for 1 minute. This should hopefully be a quick one. See if you can find the antiderivative. Now notice this is little f of x, so let's try and use your notation. What should the antiderivative be called when you do this? And we can pause for 1 minute. All right, so new exponent should have, I guess we should say capital F of x we have. New exponent's 2, divide the 1 out front by 2, we get 1/2, so 1/2 x squared. A constant's antiderivative becomes linear, so we have -3x, and then don't forget your plus c on the end. Here's your next one. So you can write it down, we can go ahead, pause the video, and why don't we give 2 or 3 minutes for this one? So we should have capital F of x, a constant in a half. Its antiderivative should be linear, so 1/2 x. X squared's new exponent should be x to the third. And when you divide out front by 3, that's the same as multiplying by its reciprocal, which is 1/3. 3/4 times 1/3 will give you 3/12, which reduces to 1/4. X cubed's new exponent will be x to the fourth. Divide out front by 4, which is the same as multiply by 1/4, which will eventually give us -1/5. And then make sure you have your plus c on the end. So it's helpful to remember dividing is the same as multiplying by the reciprocal, because we'll see fractions a good amount. Okay, we can go ahead and pause and give 2 or 3 minutes for this one. We got capital F of x equals, if we go up 1 in the exponent, the new exponent will be 5/4, because adding 1 is the same as adding 4/4. So we've got to divide out front by 5/4. Dividing by 5/4 is the same as multiplying by 4/5. So if we multiplied 4/5 times 5, that's really 4/5 times 5 over 1. So that's 20 over 5, which is the same as just 4. So we have 4x to the 5/4. Now the next one, the new exponent will be 7/4 when we add 4/4. So divide out front by 7/4, which is the same as multiplying by 4/7. The 7's wipe out, and we just have minus 4, x to the 7/4, and then you got your plus c. Here's your next one. We can go ahead and pause the video for 2 minutes. So we'll have capital G of theta here. Cos's antiderivative is sine. Sine's antiderivative is negative cos. Well, so there's 2 ways you could think of this. So you could ignore the -5 and think of this as just positive sine. Sine's antiderivative is negative cos, so a negative cos times a -5 is plus 5. Or you can think of it, okay, I'm just going to ignore the 5 and think of this as negative sine. Negative sine's antiderivative is positive cos times the 5, so you get 5 cos theta. So a few different ways you could think about it that will all yield the same answer. And again, here's a good strategy. So do your sine and cos derivatives, sine, cos, negative sine, negative cos. So wherever you are, go backwards 1. So cos, we go backwards 1, so we get to sine. If you're thinking of that as being negative sine, go backwards 1, and you get to positive cos. All right, so that's it for the in-class video. Any time left in the period, you can be watching the video for tonight.